everybody. Today we'll be talking about some functions. So we're pretty much done with the polynomials. We're going to see them again when we see the relationship between them and functions. But first we will introduce we're going to introduce functions and relations, and so we're going to see what they are. Very interesting topic. You may have seen before. Okay, so to understand the relations and functions, first we're going to start with a little table here. So if you have a table, it's made of columns and rows. Just something simple like maybe two columns, maybe one for student. And the other one could be maybe student ID, for example. So basically, for example, some random students, A, B, C. Each student has an ID. Some IDs, for example, 03, 01, 05. So basically a table is also called a relation. Another name for table is a relation. It's simply because it relates some data here from one column to the other. So the data here is related to this data on this other column. For example, student A has ID 03. So we can put that together in a pair like this. We call this a pair or ordered pair. Okay, ordered pair. And same way, student B here is associated with or is related, hence the relation B is related to the ID 01. And then also C, same way, is 05. So that is a relation. Okay, each student, as you can see, has one ID. And it has to be one ID. Okay, student cannot have, for example, two different IDs. It has to be a unique ID. So there cannot be a student here with two IDs. Another example is instead of, let's say, instead of ID, it could be something else that student might share. Okay, so something that they may have in common. For example, age. If you take three students here, X, Y, Z, they may share some age. For example, age A, age B. So a couple of students here may have the same age. Here, each student has exactly one ID. Student B has exactly one ID. It cannot be two IDs, like I said. One student cannot have two IDs. And two students cannot share the same ID. For example, student A and student B, they cannot share, for example, one ID. That's not possible. But they may share something that can be, shared by two people. For example, the age. Two students or more can have the same age. So that's also a relation. Okay, that's also a relation. We can write it in ordered pairs. A table, we can change it instead of table form into something like this, into ordered forms or ordered pairs. So what are the ordered pairs from this table here? If we want to write this in ordered pairs. What's the first ordered pair?
XA.
That's right. It would be XA.
Then
X,
then YA.
That's right. Then also YA, another pair. And the third pair is
E, or what?
Z.
B.
Z and B. Okay. So all these order pairs, basically it's the same information, the same data of this table. We just wrote it in a different formats. So So these are relations. They may also be functions. They may also be functions. Let's see when something is a function or not. Everything is a relation. Everything is a table or a relation. But some of them are functions, some of them are not. To understand this, as I was saying, one student from here, for example, cannot have two IDs.
That makes it a function.
That makes it, so a student cannot have two IDs, so it makes it not a function. So this is a function, but if we had another line here, it would be not a function. For example, if we said, again, another table for students, but we say ABC, and we said something like this. Maybe another one here. So this one would not be possible. One student here cannot be linked to two IDs. For example, a student ID or a social security number. Each student or each person has to have exactly one. Here, because of this reason, this table cannot be a function because it's not one-to-one. This one is a function because each student has exactly one ID. Each student has exactly one ID and so on. This is also a function because each student or from here has exactly one age. This student also has exactly one thing and so on. We may share one thing, but it's still each student has exactly one. You don't see a student here with two. For example, student X, you don't see it with two ages, A and B. So if it was, then we would say it's not a function. But this is a function because each student has exactly one item from here. Whatever it might be, it has exactly one. So this is a function. This is not a function, again, because of this. Okay, so a student has two things. It does not make it a function. So that's how easy it is to tell from a table whether it's a function or not. Just make sure each element from here has exactly one element is linked. There's only one line from here to here. For each element has exactly one line to one value. If one element has two lines or more to the other column here, it is not a function. Okay, so this is a function. This one is also a function. But this is again not a function because of student A. You can say because student A has two ID numbers. And again, that's not possible. So in order for something to be, again, a function, it has to be one to one from here, one also to one from here. If it's 1 to 2 or more from the other side, it makes it not a function. So everything is a relation. Some of them are, some of the tables are functions. Let me give you another one, another example. So let me just put just a bunch of values here and put some number, maybe 5 here. And also, this time I'm going to put one element here and maybe a couple of elements. So look at this one here and compare it to this one. Using this same concept, is this first relation, is it a function? In other words, does each element from here have
the first one is not a function? No, it is.
Why is it not a function?
It is a function.
It is a function, that's right. So again, because it 1 to 1, each element from here, as you can see, has exactly one line to the other column or the other value. One line, this one also has one line, this one has one line. But this one is not a function because this element has 3 lines to the other side, it has 3 values. Just like saying one student having 3, let's say, IDs. So that's not That's not possible, and that makes it not a function. So this is a function.
So different
And-
students can have a similar ID, but one student can have different ID.
One student can have exactly one ID. Okay, but different student, different students can have something that might be shared. For example, two students here, X and Y, they have something that can be shared. For example, age. People can have the same age, but some elements cannot be shared. For example, ID, they're unique, social security. But one unique item, for example, ID or date of birth or something, it cannot be replicated. It cannot be duplicated here. So it makes the relation not a function. So this is a function, this is not.
Okay, so X, Y, Z, in that case, it's students. They share some item. We called it 5, right?
Right. You could have, for example, the same age. This is just a random example, but 3 people or a whole class or half of the class could have the same something, the same age, for example. But one student cannot have 3 of that thing. For example, can have 3 ages or 3 IDs or something like that. So that's the only difference between functions and relations. So because of the 2 lines, so if one element from here has 2 lines or more, it's not a function. But if each element has exactly one value, it is a function. So another way of seeing it is through this, through the order pairs. So when we write this in order pairs, so let's write another definition. So in a function, let's write another definition for this. So in a function, each element from, for example, the first column basically corresponds or is linked to, is linked to one value or one element from the other column. Okay, so again, in a function, each element from the first column here must be linked to exactly one element from the other side, not 2, not like this. This one is linked to 2. It's linked to one element from the other column. That's another way of defining or looking at it. Let's look at it more from a different perspective by looking at this without looking at the lines in the table. So when we write, when you write the table in this form, this is what we call this set notation. We call this a set notation. And from that set notation, we can also tell whether something is a function or not easily. I'll show you how. So if we take this table, the first one here, so we can turn it into a set notation. So set basically is a group. A set is a group of some elements that have some similar attributes. They share something, for example, a set of fruits, a set of students, a set of certain types of animals, whatever. So a set is a group. So we group some items or elements that share something. So a set is a group of elements, whatever those elements might be. And usually we give it a name. We give a name for that set, for example, set of students, sets of people, whatever. Then we put a colon. Then we open some curly braces, not parentheses. We open some curly braces. Curly braces, and we put some elements inside. Some elements, whatever the elements might be, again, for example, element 1, then comma, element 2. for example, this could be names of students or types of fruits or whatever, and then element 3, and so on. And we close the curly brace. That's the format for the set notation. The name changes depending on what you're grouping. Then you have a colon here, 2 points, not semicolon, but 2 points, colon, and curly braces to enclose all the elements inside of it. Example, maybe you want to call this, make a set and call it fruits, for example. Fruits you like or fruits you need to buy or something like that. So you're gonna write the name of the group, the colon, then the curly braces. Then you list your fruits inside, for example, bananas, comma, apples, oranges, and that's it. For example, this group has exactly 3 elements. That's it. These are your favorite fruits or the fruits you want to buy or something like that. That's set notation. Now we're going to apply that to this. We can change tables from this form of a table with columns and rows. We can write it in the form of a set notation. So we're just going to need a name for it. We're going to need a table first. So again, student, for example. And then we're going to follow this by some number, or it could be on any other elements. A student table, there's a lot of information that, for example, that you provide to the school when you register. So there's your name, your address, phone number, and a bunch of things, like maybe it could be up to 20 or whatever columns. But let's just make things simple here. So let's say, for example, we have 3 students, A, B, C. And again, just going to do some IDs. So to write this in set notation, so again, we're going to need a name for the group or the set. In this case, it's a table of students. So we may call it student ID, for example. Okay, just going to call it student ID, whatever name you want to give it, doesn't matter. We're going to follow this again by colon. And you open your curly braces. And inside the curly braces, we're going to write all the pairs. So the elements of this notation set or set notation will be all the pairs of this table. So what is the first element or pair of this table? Everybody, what is the first element?
A.
A01.
A, 01 or 07, whatever it is. Okay, make it 7. Okay, that's our first element. First element here is a pair, so 1 pair. Once you're done with the first element, comma, and the other element. So this element is done, comma, and the second one will be the other element or pair.
B2.
That's right, B02, comma, finally, C.
Zero
05.
005.
01, 02, 03.
That's right. And then you close the curly brace. This is just another way of writing the table. Instead of columns and rows, we use set notation. Name, colon, and all the pairs. Pretty simple. And let's do another one. So we can see, we can also tell from here whether it's a function or not. If you don't have a table, if you don't have those lines, for example, you have the lines, you can tell. But if you don't have those lines, you're just looking at this, we can also tell from here. I'll give you a second one, and we're going to tell from that. Maybe let's take something like this for the same one. And we're going to understand how to tell whether it's a function or not without looking at the table, just by looking at the set notation. Set notation. Some students again. And maybe we're going to use age again here. This one age, maybe B and C. So looking at the tables, so that's a function. Is this a function? Is
No.
this one?
Yes.
It is a function. Each one has 1. Each one has 1. They may share something. That's fine. But The thing that doesn't work is if you have two lines going from here to here. For
Are
example, this
there
line,
two y, right?
what is it?
Or what? They are x, y, z in the first column, right?
Mhm. That's right.
Oh, yeah.
So each one has one line. Each one has one line. So this is fine. There's no problem unless you see one with two lines. You see one element with two lines or more, that would make it not a function. So this is a function. This is a function. What if we change this a little bit and make it like and change this one a little bit, so to make it like this. C and D, we're gonna make this like that, and also here and here.
Not a function.
Not a function, that's right, because this student here, or whatever this element, it has two lines. There's two lines from here to here. So this is not acceptable when it comes to functions. This is not a function. So let's write it in set notation and understand it more. So we're going to call this, we give it another name again, student. Just call it whatever. The name is not that important. It could be anything, but it's better if it's something meaningful. For example, students. Then colon, open the curly braces, and let's list all these again elements or pairs here and see the difference between them. Okay, what are the pairs here? The first pair.
XB,
That's right. So XB,
XC,
XC, X again, as you can see, because it has two elements.
IC, and ZD.
That's right. Okay, so now ignore the table here, ignore these tables. If we didn't have this, how can we tell just by looking at these? So we said this is a function, we established that. This is not a function. And again, let's see how to tell whether these are functions or not from here. So what exactly makes this one a function and this one not a function, just by looking at them? Maybe start from here. What makes this not a function in this set notation?
The first element has two second elements.
That's right. And that element is? Which element is that?
X.
X.
The X.
X, X,
In other words, that's right.
Oh.
The X is repeated here.
We
So
can
the
give
X-
x two values.
That's right. X cannot have two values. If it's going to be a function, it cannot have two values. It's still a relation, just a relation, but not a function. So functions are more strict. So 1 for 1. So you can tell from here, if this one is duplicated, then it's not a function. Here, all these are unique. A, B, C. Here we say a function, we say function. Or if you're looking at it from here, the first element of each pair is unique, is distinct or unique. Distinct meaning it's not repeated. That makes it a function. Okay, so that makes it a function here. So the first elements are not unique. The first elements is a duplicate. So X is duplicated or repeated. The opposite of distinct. Distinct elements are different elements. Each element is unique. But here, the first element, or we can say X, the element X is duplicated. So duplicated just means repeated or replicated.
Means unique.
What is that?
Distinct, it means unique.
That's right. So distinct is unique. So X is the opposite basically of this. So for this one, the first elements are not distinct. They are duplicated, as you can see here, the X and X. So X is duplicated. And that makes it not a function. Only the first element we care about, not the second element. You see how the second element here is repeated? but doesn't matter. We don't look at that. We look at the first elements only. If they are distinct, it means all different. It means that's a function. If not, if one of them or more are repeated, so say not a function. Okay, so it's very simple to tell. So the whole thing here, again, we just to explain the difference between relations and functions. So relations and functions could be in everything is a relation, by the way. All of these are relations. Every table, every group like this is a relation, but some of them are functions, like this one and that one. And we can tell either by looking at the table and see the relationships, see these links between the elements, or you may also tell from the set notation. So set notation, remember that. Name, colon, curly braces. And again, we can tell, let me give you another example. We can tell just by looking at this, without looking at the table. I'll give you another relation or another example. You can call it anything. Sometimes we just call it the R for relation. And I'm going to put some elements here. And we're going to figure out whether this is a function or not. So we put, for example, 3, 4, 7 and 4, 2, for example, minus 5. Is it just from random values, random pairs? Could be anything, could be some variables here, could be some numbers. So so it's auto one, and let me give you another one. No tables, okay, we're just going to tell based on the relation. And let's make this maybe a 5, 3, 2, 1, and 5, 8. Okay, so let's see if these are functional or not. The first one, is that a function?
First one is function, second one is not function.
That's right. So this one is a function because you look at the first elements, 3, 7, and 2, they're unique. They're different, no duplication. So that's good. So this is a function. So again, these are different. But here, if you check the first element, we have a duplication here. So that's duplicated, the 5 and 5. It doesn't matter if the second one is repeated, that's not a problem. This could be, for example, age. One student has this age, another student has the same age. That's not a problem. But here, one student cannot have the same of unique attributes, unique or distinct attributes. So for example, student having some ID and the same student again appears here. That's not good. It's not unique. So not a function. Okay, 5. Let's say 5 is repeated. That's right, repeated or duplicated. Okay, so we saw the table, we saw sub notation. Let's see another form. So should be pretty simple to find the difference between functions and tables and the relations, and it can be very quick. It doesn't take longer than a few seconds. Okay, everybody, you understand the definition here and the difference between the functions and the relations? Everybody?
Yes.
Okay. Any questions, everyone? At this point, it's very important to understand this stuff because we're going to be using it for other topics about functions in the next maybe at least 2-3 classes. So very important to understand these notions and these fundamentals. Because once you understand them, you can basically, there's a lot of these questions can be answered, like I said, in a few seconds, instead of just staring at it and not knowing what to do. If you understand it, it should be very simple to do, like changing this into this or finding out whether something is a function or not. It shouldn't be that bad. So please let me know if you have any questions, everybody, before we move on to the second thing. Next thing I'm going to talk about is another notion. So we saw set notation. Now I'm going to talk about the domain and range of a set. Okay, number 3. There's a lot of terms today, a lot of new terms. Not necessarily complex, pretty simple. Each one, defines or stands for something. So this is another one of those. So domain and range. This is very simple again. All it means is, again, if you take some table, some elements, and whatever this is, X, Y, could be student ID, whatever it is. And you have some elements here and some corresponding elements on the other side, whatever values those are. So the domain is simply the first column by itself. That's all what it means. And the range is the other one. Domain and range, domain, range. The first elements, basically, of the table, and the second elements, we separate them. We write them in set notation separately. Instead of writing them together like this, we write them separately. So this is the domain. And this is the range. So again, for set notation, you're going to need a name, colon, and elements, all the elements inside curly braces. So first one here, the first set. So we're going to write both in set notation. So we're going to need a name. The name is domain. Sometimes we use just a letter D. So domain followed by colon, and then curly braces. And what do we list here inside the curly braces? What are the elements of the domain? That's right. All these elements separated with commas. A, B, and C. So the domain is only these together. And the range, of course, is the other set, which is
0.0301.
That's right. And these we can arrange. If we have numbers, we can arrange them from the lowest to the highest. That's a better way of presenting them. That way we can easily search or sort through them if we're looking for a specific value. These might be arranged in alphabetical order, I believe, but especially for the numbers. So arrange them from the lowest to the highest. So you can easily find if you're looking for a specific value, you know what to look, the beginning or the end or the middle. So that's it. That's all it means. Domain range, the first elements of each group. And if something is repeated, we don't write it twice. For example, if a number or a value is repeated, we don't write it twice here. We only write the values once. Even if they're repeated here or here, we only write them once. Show an example. If we take that, let's take that example here. Let's write this. I'm going to write this in the domain and range form. So here, basically, we have both of them grouped together, both the domain and range together in this notation. So that's the whole set. Now let's write the domain by itself and the range by itself. Because they're two separate groups. So domain again, colon, curly braces. What element of the domain go inside these curly braces? First set.
3, 7, and 2.
That's right. We have 3, 7, and 2, and we arrange them 2, 3, 7. That's it. Then the range is basically the second element, which would be the range here would be we have 4 and 4 and -5. So no need to repeat the 4. Okay, no need to repeat it. Just once is enough. No need to repeat that. That's it. So you can easily take anything, table or a sub notation like this for a relation set. And we put it into the domain and the range by itself. So that's a table. This is a another name for this is relation set. When we write things in this form, as opposed to the table. Hey, that's very simple. Again, I'm going to get back to these later. Domain and range, all these notions, all these concepts we're introducing now. I'm going to talk about each one of them in detail in the future. So it's very important to understand what each one means. For example, next class, everybody should know what the domain and the range is when we use it for other things. So set notation, domain and range. We have another notation, but we're going to do it another time. So domain and range. So far we've seen about 2 or 3 different ways of basically presenting information. We saw tables, we saw notation sets like this. We also saw some groups. This is not necessarily a table, just a group of elements. Usually we use them like this in a group. It's not necessarily a table, but just a group of elements, and they have a relationship between them. Sometimes they're functions, sometimes they're not. For example, here, not a function. So we've seen tables, we've seen groups, we've seen set notations. What is another form of presenting information? A very common and visually appealing one of presenting information. What is that form? Another form. When you have a lot of you have data and things and numbers, what is the best way to present them so you could understand them quickly and easily, instead of putting them in tables with millions of rows and columns or lines of this? What is that easy way to present information? Everybody, you have another form. What is it? Again, think about something that's can be easily understood visually.
I don't know the name, but I think that line, like Lena.
What
The
line
graphic
again?
one. The graphic
Graph.
one.
Graphs, exactly, the graphs.
Yeah, graph.
That's right. So we use graphs to to present, project information. And graphs can make us understand it and make sense of information better. It's actually the difference between data and information. It's basically whether the data is sorted and is made sense of by graphs, by graphing it and understanding the pattern of it, or by just putting raw data in a table. So let's talk about graphs a little bit. So again, there's a difference between data, which is a plural word. The plural word, the singular. What is the singular form of data? Data is actually plural. When you say data, you should say data are, not data is. A lot of people misuse this, but the singular term for data, does anybody know? It is datum. So for one, okay, here, for many. One piece of data, one piece of something is datum, but when you have a bunch, we call it data or data. Basically a raw, basically data is not, so there's just raw information. Or raw numbers, or something you collect. You just collect information. For example, a table, you take all the names of students, all the IDs, all the addresses, and you accumulate that data into a table, into a form or something like this. But later, when you analyze that data and you understand it better, and you make graphs of it, for example, the demographics, you say, oh, this and this, and maybe you sort the students by race or by major or by ethnicity, whatever it is, that becomes information. So data is raw. You can think it is raw numbers. Raw numbers or pieces of information, whatever. But information is more information makes more sense and it's sorted out. So you can say data that have been analyzed sure you've heard of data analysis or something like that. Or you see graphs in general, any graphs or maps, or see people breaking down the numbers and try to understand why the numbers are the way they are. So that's basically what information is. We understand the data that have been analyzed and sorted. And you make sense of it. You make maybe graphs out of it. You make formulas. You basically you studied it. You take some raw data, raw information that's in tables, and you make sense of it. There's a little note there for you. Difference between data and information. It's not the same thing. So for this reason. All right, back to our graphs. So we can present things like this, or like this, or groups. We can also use graphs. Today we're not going to make graphs. We're just going to give you some random graphs. We're going to just study them, but we will see how to make our own graphs in the future. Graphs of functions. So let me just give you some random ones. As you know, graphs can take any shape or form depending on basically the data. So the data put into the graph, it turns into some information. It's based on what you're dealing with, where the data comes from. So you could take different shapes. For example, maybe something like that, maybe something like this, and maybe like this, or even something like this. We're going to learn how to make these. Okay, we're going to make these based on some table, based on some formula. You can make your own graphs. For now, I'm just going to broadly talk about them, and we're only interested today is in knowing whether the graphs here are functions or not. So we learn how to see whether tables are functions or not. Also, relation sets. We learn how to see whether they're functional or not by looking at the first element. For the graphs, it's also pretty simple to see whether something is a function or not. First of all, this is what do we call this axis here, this line, and what do we call this line? Everybody?
X
This is
and
a
Y axis.
X and, that's right, X and Y graphs. So two-dimensional or Cartesian graph. Only 2 dimensions. We have the horizontal axis, the vertical axis, the X and Y. That's the graph itself. And this is, let me change this graph a little bit. Complete. Okay, we'll be back to this one in a moment. So there you go. So basically, let me make it like that. Some random graph, it doesn't matter the shape at the moment. So it's very easy to tell whether something is a function or not. We do what we call the vertical line test. The vertical line test, meaning a line that goes through the graph. Goes through this graph. How many times does the vertical line meet or intersect with the graph? Anywhere on the graph, how many times will it intersect? Meets once, right? Meets once here. But anywhere you do that vertical line, this broken line here, will only meet once, anywhere on this graph. What about on this graph? This C-looking graph. If we draw the line through it, the vertical line, how many times will it meet?
2.
That's right. If you do the vertical line, it's going to meet here and also here. And for this straight line, the vertical line will meet
Once.
That's right. Just once. Anywhere you draw it, it's going to be once. What about this?
2 times.
1.
Once, the vertical, not the horizontal, the vertical line. So anywhere you do that vertical line,
But four of them are functions, right?
not all of them, no. We're about to find out. So this vertical line test is basically what tells us.
I think that the one that's me 2 times is not a function.
Correct. That's exactly right. So the vertical line test. So it's very simple. Again, all we need to know today is whether it's a function or not. Don't worry about how to draw the graph. Why is it shaped like this? We're going to learn that in the future. So this is, because it meets once, it is a function. So function, because again, the line meets for the graph once. This is not a function. Simply because the vertical, again, it has to be vertical. It cannot be this way. It has to be a vertical line, not a function. This one obviously is.
It's a function.
That's right. It's a function here. And finally, also once. It's a function. So basically, let's put this in a sentence. When the line and the vertical test line or line test meet the graph once only, it's a function. And of course, more than that is not a function. Okay, so the line meets the graph. When the vertical line test intersects or meets the graph, intersects. Intersects with the graph once only, okay, not more than once, it is a function. Other than that, if it meets, for example, 2 or 3 times, or more than once, it is not a function. So again, that's basically referring back to the duplicates and the distinct values. So this is basically a duplication here. This meets twice, so that's a duplication, but if it's once, it's unique. So functions are unique, are distinct, because the reason why we say that is because basically a function is something that takes you from point A to B. Function, it takes you from point A to B. Function, for example, F for function. So every time you're guaranteed that if you go from A to B, there is one way to get there. And it cannot be a different value. So if you go from A to B, there's only one way. You can't, for example, one time go from A to B, another time from the same point you go to something else, for example, C. So that doesn't make sense. It has to be distinct and not distinct. It has to be what's the word? It has to be reliable. That's one of them, and also consistent. That's what I was looking for. Consistent. For example, if you check a table for student A, the ID will be 5. If you check it tomorrow, if you check it the next year, the ID should be 5. You can't check tomorrow, you find 5, and next day you find 3. So that's inconsistent. So this is inconsistent here. But with functions, it's like a formula. Function is actually a formula. So if you plug something into it, you get the same result. You plug something into a function, whatever it is, you get the same result. So you can't have a different result by plugging the same thing. But we're going to see this later in details with actual numbers and functions. What else? So we saw the function notation, domain range, set notation, and the graphs. That should be it for today. It's a lot of introduction here. all these terms. But again, we're going to expand on each one of these terms. We're going to make our own graphs. Starting from next class, yeah, we'll see how to make these graphs ourselves. They take all sorts of shapes. Could be like this, could be a line, could be that. All sorts of, there's even graphs that look like this. But we're not going to study these. We're just going to see something like this. Yeah, so for now, just remember the basics here. How to tell whether something is a function or not. That's it. That's the main thing today, is to how to tell whether something is a function or not, and also know what's the domain, what's the range, what is set notation, and how to turn a table into this. So today we turn tables into relation sets. Next time we're going to see how to turn tables into graphs like that. But before we have the tables, we're going to need something to make a graph. And to do that, we're going to need the function itself, the mathematical formula. So that's what we're going to introduce next time. You're going to see the actual formula that we use to generate tables, generate graphs, generate set notation, and so on. So we've seen everything today except the function itself. We just talked about it. This is the outcome of the function, basically. But next class, we will actually do the actual functions. Okay, everybody, any questions about the graphs or anything else we've talked about today? And this is very important for the next 2 or 3 classes. These basics we have to understand well so we can use them properly. And once you understand them, like I mentioned before, a lot of this stuff you can answer in seconds. For example, this vertical line test, you can do this in 3 seconds. Just by looking at it, you can decide. But if you don't understand it, you could be looking at it all day and you wouldn't know what the answer, and even I wouldn't even understand the question when I say, is this a function or not? So, so please let me know if there are any questions. If not, probably write down a couple of problems for you, some practice problems. Okay, practice, and let's see, decide or determine whether the following, whatever it is, table or whatever, is it's a function or not. Write the domain, write the domain and range in set notation. These are the typical questions you will see in the homework or exams, something just like this. Here's another notation we're going to learn last time. This is set notation. We have another one. They're quite similar, but we'll do that next time. So sometimes, again, we just use groups like these. We don't use numbers. And let's see. Okay, so determine whether these are functional or not. Write the domain and range in set notation. Also, give you some relation here. Same thing for this one. Maybe another one. And another question, are these functions? It's 1, this is 2. And it's yeah, it should be maybe one like this. Okay, so that's should be good. Everybody, so look at these. Again, this take seconds. Again, based on what we've done today. If you know what you're doing, this should take you seconds to answer. I'll give you a few minutes to work this out.
Professor, I'm
Mhm.
back. Can you please scroll up? I need to screenshot the first, like the beginning of the class. Can I do a
You'll find
screenshot?
you'll find the whole thing on Blackboard. Okay, very similar, or this one, the whole video later. Okay,
Same
no need.
thing.
Yeah, you won't. No need to screenshot. Better watch the whole video. You won't understand if you read it. You will not understand it. But just watch the video to catch up on it. Okay.
Okay.
All right. So that's the practice,
R,
everybody.
R1, R2, it's already set the name, it's set notation, right? R1, R2 with braces, it's already set notation.
So we need the domain and range by themselves separately in set notation. This is the whole thing together, but we need to break.
Domain.
Okay, everybody, take a few minutes, maybe give you 8-9 minutes or so. And we'll go over this together. Again, this will take us probably a minute to do all these. So look at them. We'll be right back in a few minutes. Everybody, you're done? Everyone?
I can try.
Okay. Everyone, so for the first one here, first of all, determine whether following, it's even incomplete, okay. Let's talk about this one here. Is this a function? The first one.
5-3.
It is a function.
It is a function, right? So this is a
It
function.
is the function, yeah.
Okay, so determine whether the following, I should have said here, is a function. That's what I should have said. Then write the domain and range in simultaneous. So we said the first one is a function. Okay, and it's a function. So let's write the domain and range separately. So the domain is
5,
5,
5, 6,
3,
5, 6, 7. Right? The domain, the first group, and the range is the second group,
4.
3 and 4. That's right. And okay, what about this one? Function or not?
Not function.
Not a function. That's right, because the 2 here has 2 lines and 2 elements, so not a function. And after that, we need the domain also on the range. What's the domain of this?
8 to 4.
That's right, so 8, 2, 4. So we're going to arrange them. Need to arrange them, and then we have the range, which is
1, 4, 7.
right 1, 4, 7. The domain and the range, and not of one is function, one is not. This relation set here. First of all, is it a function? Is that a function?
yes.
Function, yes.
Yeah,
Yes. So all these elements are unique, so a function. Very good. I'm gonna write the domain. What is the domain here?
-3,
-3,
1, and 3.
Okay, that's right. For the first elements, we arrange them from the lowest to the highest. Then the range, same way. So what do you get?
2, 4, 2, 4.
2 and 4. That's right. 4 is repeated, so we don't need to write it twice. Just need to write it once. That's it. Function and the domain and range. Next one, the same thing.
It's
Function
a
or not.
function. It's a function.
It is a function. That's right. You have 2, 4, and 7. It is also a function. Unless if you had a duplicate here. So this is a function. You got the domain and the range.
2, 4, 7.
That's right. 2, 4, 7. And the range is
1,
1.
and 5.
That's right. Just 1 and 5. 1 is repeated. So that's how simple this is. And for the graphs, these functions. First one.
Is function.
That's right. So anywhere you do the vertical line, only meets once. So this is a function. What about the next one?
Second one is not a function.
That's right, not a function, because if we do the vertical line test, that meets vertically, meets twice. So that makes it not a function because there's a duplicate here. Finally, the third one, apparently,
Is not a function.
that's right, it meets the graph. The line meets the graph a bunch of times. So one here, the other one here, and the other one here. So not a function. Okay. Okay, so that's our introduction to functions. Again, make sure you understand these concepts and notions. They're very important. We'll be using them for the next few classes about functions. We're going to get into more details today, just a little introduction, a little definition here and there, but we're going to discuss this in detail starting from the next class. Any questions here, everybody? About any of these questions with the practice? Everybody, any questions?